Greetings everybody, and welcome to our next example on cross products. So what we're given in this problem is a vector r of value 6i, and we're asked to determine which is greater in magnitude, the torque about the origin O when the force F1 is applied at the point P at the end of the vector, or the torque about O when the force F2 is applied at P. And so the thing that we need to kind of remember, or at least to know about this problem in particular, is that our torque is really just going to be equal to the force vector cross the lever arm vector. And so kind of the idea is you have a point O here, and you've got this lever arm that's going to be of magnitude whatever it happens to be, and then the idea is you are applying a force to the end of that vector P. Now, if this lever arm is rigid, what's going to happen is that force is then going to cause a torque. A torque, or kind of a force of rotation, if you want to think about it that way, is going to cause a torque around that point O. And how do we get that? Well, the torque is actually given by the cross product of the force and the lever arm R. And so in this case, we just really look for which torque is going to be greater. Well, we just compute two cross products. So the torque about the first lever arm is going to be, or the torque about the point O is going to be the first vector, which is going to be our 2i, or 2i minus 4k, and that's going to be crossed with our value r. And r in this case is going to be our 6i. So we can use the distributive property so that this looks like 2 times 6. So we have a 12 of our I cross I, and then negative 4 times 6 is a negative 24 of k cross I. Now, one thing to remember is that when we have a vector crossed with itself, it's automatically 0, so that value is going to be 0. And then for our k cross I, we remember our cyclic permutations, and so what that's going to give us is our value of I cross j is going to give us k. Then we permute cyclically, so everybody shifts over to the left, and we have j cross k, giving us I. One more cyclic move, and so we have k cross I, then giving us j. And so in this case, we have our k cross I, so that's going to give us a value of j, and so we end up with just a value of negative 24 times j. If we do the same thing for our second torque, that's going to be our second force, which is 5i minus 3j. And we're again crossing that with our lever arm, 6i. And so what happens? We distribute again, so we have a 30 of our I cross I, but that's going to be 0, and then a minus 18 for our j cross I. And now for our j cross I, remember what this is. If we switch the order, then it gives us a negative, so then this becomes a plus 18 I cross j, which is a plus 18k. And so what we can see in this case is which one is going to have a greater magnitude. Well, the magnitude of the first torque is going to be 24. The magnitude of the second torque is going to be 18. And so the first torque gives the greater magnitude. I hope you've enjoyed this video, and I will see you guys in the next problem. Take care.